Hello everyone. So my name is Alan John C. Olivete from EV class of Mathematics in the Modern World. So today I'm gonna show you how is it related, the Rubik's Cube, to the group theory. Come join me. Let's go. So once again we're back. So as I said earlier, I was going to relate Rubik's Cube to the group theory. But first, what is a Rubik's Cube? Are you familiar with the Rubik's Cube? So a Rubik's Cube, as you can see in the picture, it has different colors. It has 6 different colors in each side. So today I'm gonna show you all about 3x3. Only about 3x3, because actually there's a lot of different kinds of Rubik's Cube, such as 4x4, 5x5, but honestly I just know how to solve the 3x3. So for sure you guys are familiar with the Rubik's Cube already, but still I just want to define what is it all about. How is it related? So what is a Rubik's Cube? So a Rubik's Cube has 26 small cubes that can rotate through central axis. So overall it has 26 cubes, small cubes that can rotate, and it also has one centerpiece that never changes. It's, for example, the yellow one, as you've seen in the presentation. So it will never change as you solve it. So that's your goal, to solve it all with same centerpiece. It has 6 pieces. It also has 2 edge pieces, as you've seen in the center in the cross, the yellow one. Just try to imagine it has yellow and red. So definitely it has 2 edge pieces, and it has 3 corner pieces, which contains, as you've seen in the picture, it's the side of the Rubik's Cube. For example, the yellow, blue, and red. So who invented Rubik's Cube? So Erno Rubik invented Rubik's Cube. So imagine he is in the picture. He is old right now. He was a Hungarian inventor and a professor in architecture from Budapest, striving to teach his students 3D geometry. So making the Rubik's Cube was an inspiration to them, because he wanted to teach his students 3D geometry, and one way to teach them is by making and inventing the Rubik's Cube. That's why it was named the Rubik's Cube by his surname. Anyways, he also graduated from Budapest Technical and the Academy of Applied Arts and Design, where he studied sculpture and architecture. Imagine, he was also in architecture. So he's great. He's awesome for me. And imagine, he was just an ordinary boy wanting to do everything possible and not possible. So that's Erno Rubik. So now we will define what is a game theory. A game theory is a study of symmetry that arises in puzzles, visuals, arts, music, computer science, and all throughout mathematics. It is a branch of abstract algebra and deals with how individual elements interact in the group. Relating to the Rubik's Cube earlier, the elements are the phases of the toy. So as I said earlier, the center one is equivalent to a phase of a toy. So anyways, group theory has 4 axioms that are related to Rubik's Cube. Now I'm gonna discuss to you what are those 4 axioms. Let's start with the closure. If you add or multiply any two elements in the group, the sum or product will be another one of the elements of the group. Or in other words, it is a set of actions that will never change. So just like this one, this is a sample of it, the closure. And this second axiom is associative. The parenthesis could be placed anywhere if multiple elements are added or multiplied together, and no matter what, all would yield the same result. In other words, grouping together by placing parentheses without changing the result. For example, 2 plus parenthesis 1 plus 3 is equal to parenthesis 2 plus 3 plus 1. So obviously both is equivalent to 6. Because when you add them together, even though there is a parenthesis, it will still have the same result. So that's associative. So the third one is identity. There is one element for each addition and multiplication. When added or multiplied to original number, they yield the original number as a result. And in other words, an element that is applied to another element, it will still result in the same element. For example, in this, as you can see, 3 plus 0 is equals to 3. So because another element is still the same because it's 0. So last but not the least, inverse. There is an element for each element. When added together will yield 0, and another unique element for each element that when multiplied by the original will yield 1. For example, 1 plus 1 is also inverse of 1 negative 1. So it's vice versa. So that's inverse. So it's the opposite, in other words. So here is the sample. So once again, to summarize all of the of what I had discussed today, a group theory is a collective set of elements that can be applied to two elements of the set. So just like earlier of what I've discussed, so there are 4 types of axioms in group theory, and some of the puzzles, specifically what I've shown you earlier in the Rubiks Cube. The first one is closure, which is a set of actions that will never change. So whatever you do something, it will never change. Whether you rotate clockwise or counterclockwise. Associative, it's grouping together by placing parentheses without changing the result. So same goes with the mathematics. Associative, even though you put parentheses, it will never change. Identity is an element which makes an element remains unchanged. Last but not least, inverse. When added together, it will yield to 0. So once again, thank you for listening, guys. I hope you learned something from me today.